And that's the similar type of graph by Ventil showing for different states. And there we have a little bit of the, we might have a little bit of the spaghetti problem, that there are a lot of different series. We have a little bit too many repetition in the axis, so they might have removed that. On the other hand, it's sort of, maybe we're not so concerned about the spaghetti things because we can see that basically what do you think the point is that accompanied this graph? Yeah.
So as the household increases, it matters to us that they're all the same.
Exactly. So we can see that there is a lot of regional differences in the low percentiles. There is a lot of regional differences in life expectancy. You know, if you go at the 2.5, like the lowest percentile, you're much better off living in New York than living in Detroit. But around the 10th ventile of households, which is the median households, those differences become essentially negligible. So here, the fact that we have many graphs on the same, many lines on the same graph might not be too much of an issue, because at some level, the story they're trying to tell is that those things will become the same. This is one that we saw that I really like as another way of sort of telling the entire story of a research strategy and the research result in one picture, in a few pictures. It's the Greenstone and Co. paper on the Huai River. If you remember the story on the right, on the north of the river, they had subsidized coal for the heat, and in the south they didn't. And what they look at is in this graph, oops, I cut the legend, the particulate matters. And the story that they want to tell is that on the north of the river, there is much more pollution than on the left. And then they have a similar story for mortality. And then we can tell, so this is a map version, but although it's a map, it's not just a map of China, it's a map that has data on it, so that's definitely a visualization. And then that's the graph version, where you can see, so that line is very important. It's the threshold, a regression line fitting around the bubbles. The size of the bubbles tells us the size of the city, the jump, and the other side of the bubble. And here you have a little bit even a caption inside the graph that really explains what is going on. We might have make it a little bit lower. So there is a lot of data in here in the sense that the size of the bubble is meaningful, the threshold is meaningful, there is attention, pre-attentive processes on the jump, and also we even changed the color to make that simple. So that's for pollution, and that's for life expectancy.
Do you have to explain that the size of the bubble is the size of the city, or is it like normal?
It should be explained somewhere, probably at least in the text, but usually in something like that, you're gonna have a caption with some of the details. Yeah, yeah, a legend to the thing. By the way, if you were doing, so you need to that. If you see, for example, here. You have this very long caption because of this rule that the graphs should be self-explanatory, and in scientific and medical journal they take that rule very seriously. So all of the details are in there, explaining. But if you were to present this you wouldn't show that. So you have to also remember that when you move from a text to a presentation in class or to donors or whatever, you're going to further reduce the detailing. So you might go from something like this to something like this.